Next interesting part of this random variable is to find out the mathematical expectations of the random variable. Because whenever we want to solve the particular problem or we want to predict something, for example of the share market. So if you take the share market of the some particular company, so the prices of the share market are going from some values to the some values. There is a lot of variations every day, intraday, interday, or within a year or within the 10 years, etc. So if we want to guess something, so that we have to model with the help of some probability distribution model. So generally we are using the Gaussian distribution model or the uniform distribution model, or number of models are there. So in that particular model, we are finding the mean values, we are finding the mean square values, or we are finding the variance, or we are finding the standard deviation. So from the standard deviation or the mean values or something, we will get some information, and from that we can predict something. For example, if we want to predict how much rainfall will take place for this particular year, so if you want to predict something, we have to take the data of the last few 10, 100 or the more than 100 years, and if you find out the mean values of that rainfall, so you will get idea that so how much rainfall is taking place on an average, and from on an average, so definitely you will get some idea. Even if you get some variance or if you get the standard deviation of that particular the problem, so you can exactly find out that for this particular duration what will be the probability, or for this particular duration what will be the probability. So therefore the finding the mean values, finding the standard deviation or finding the variance are very useful to model the particular problem, and that is going to help us to predict anything in our life, and it is being used everywhere. Even in the artificial intelligence tools, AI tools also, such type of the probabilities are being used, and from the probabilities we are getting lot of answer. So mainly the statistical parameter we are using for the probability density function, if for the continuous the random variable, the 4 parameters which are used to solve the problem of the probabilities are: number 1 is the mean values. Okay, this mean value is also called as the expectation of the random variable, and that is represented by capital E of x, that is the expectation of x, that will give you the mean value of the probability density function, that is equal to minus infinity to infinity. So the x into this probability density function integration. So x is only the parameter that is giving you the weighted value, and from that weighted value we are getting the mean values. The second thing, another parameter which is useful to predict about that the particular probability is a mean square. So this mean square is given by E of x square. So this is equal to minus infinity to infinity x square into fx of x into dx. Third very important parameter which is being used to predict about that model is a variance, and this variance is given by the sigma square, which is equal to E of x square, that is a mean square value, minus square of the mean values E of x square. And the last parameter which is being used, which is one of the important measure for the probability model, is the standard deviation, that is the under root of sigma. ये अगर 4 चीज या 4 फॉर्मूला आपको पता है, तो you can find out the statistical values of that particular probability density function, and you can predict many things about it. Okay, so this is about the expectations, and sometimes so they may ask you some problem on the expectation. That time sometimes we require so these properties of the expectation. A properties है E of ax is equal to a into expectation of x, then expectation of x plus y is equal to expectation of x plus expectation of y. Expectation of xy is equal to expectation of x into expectation of y, and this expectation of ax plus b, where x is a random variable, is equal to a into expectation of x plus b will be there. So these formulas are used to solve the problem of the expectation. Now look at the some problem for example for the probability density function. So fx of x is equal to 0, x is less than 0, 0.02 x for the values x between 0 to 10, and 0 x is greater than the 10. So they will ask you to find out the mean, they will ask you to find out the mean square value, they will ask you to find out the expectation of the 2x plus 3, they will ask you the variance, they will ask you the standard deviation, and when you put the standard deviation, mean and the variance, you can model that particular the problem, and you can guess and extract many information about that particular random problem. Now we will find mean square value and the expectation of 2x plus 3, variance and the standard deviation. We know the formula for the mean. So mean is also called as the expectation of the x, that is E of x. So that is equal to minus infinity to infinity x into this probability density function into dx. Okay. So this probability density function is available only for the values between 0 to 10. So limit for this will be from 0 to 10 into x into fx of x is the point 0 to the x into dx. So this is equal to 0.02. The limit will be from 0 to 10 into x square into dx. So this is equal to 0.02. Integration of x square is x cube divided by 3. It will be from 0 to 10. So this is equal to 0.02 into 10 raised to 3 is the 1000 minus lower limit, that is 0. Okay, and it is 1 by 3 will be there. So this is coming out to be this values 6.66, it is 7. The next, they asked us to find out the mean square value, that is E of x squares. So this E of x square is equal to minus infinity to infinity x square into fx of x into dx. So this is equal to, again the limit will be from 0 to 10, it is x square into 0.02 into x into dx. So this is equal to 0.02 into x cube. The integration of x cube is x raised to 4 by 4. The limit will be from 0 to 10. So accordingly this is coming out to be solved. It is 50. And next we have to find out the variance. So this variance is represented by the sigma square. So that is E of x square minus E of x, it is square. So just to substitute value, E of x square sigma square is coming out to be 556, and the standard deviation is the square root of this is equal to 2.3570. Next problem is asked about to find out the 2x plus 3. So here only I will solve. So this expectation of 2x plus 3, this is equal to 2 into expectation of x plus 3. So you know the values of the expectation, it is a 6.667. So multiply by 2 plus 3, so it is coming out to be around 16.334. So like this you can find out the mean square value, this E of 2x plus 3, variance and the standard deviation. Such type of problem will be asked in the examination. Let us see one more problem. Similarly, same they have asked for the PDF, fx of x is equal to this x square. Find the mean square value, variance and the standard deviation. So this mean is again given by E of x is equal to minus infinity to infinity x into fx of x into dx. Just to use the simple formula for this. Then mean square value is given by E of x square is equal to minus infinity to infinity x square, the fx of x into the dx. Then variance, that is sigma square is equal to E of x square, that is a mean square value, minus E of x the square, and the standard deviation is equal to under root of 6. Okay, so if we solve this, we will get the expectation value, that is 1.4, and mean square value 1.5, variance 11 by 80, and standard deviation is the square root of this, it is a square root of 11 by 80. Such type of problems will be asked. So if you look at this chapter which we have discussed about the random variable, then the discrete random variable, the continuous random variable, properties of the CDF, problem on the CDF, properties of the PDF, problem on the PDF, then the expected value of the random variable, the mean value, mean square value, variance, the standard deviation. So accordingly this random variable, CDF and the PDF are used to model a particular natural phenomenon, and from that you can get lot of information and you can predict behavior of the any natural system, and that is going to help us to solve the natural problem, and that will help us to make the life of the human being very comfortable. So I hope you understand the particular video, and you will develop lot of application for the society, and with the help of this probability, CDF, PDF and the expected values of the random variable, we could able to contribute to the society. Thank you very much.